Hello there, and welcome to the Sleepy Astronaut, where wonder takes wing and science settles softly into dreams. Tonight's gentle expedition explores one of nature's most reliable rhythms, yet curiously misunderstood phenomena: why the seasons change on Earth. It dances through our year, bringing blossoms and snow, harvest time and hibernation. But what cosmic choreography creates this eternal waltz of warmth and cold? Before we drift into this celestial story, I'd love to know where in the world you are watching from and what season you are experiencing right now. Fitting, isn't it? A video about seasons, and here we are scattered across the globe, each of us wrapped in our own seasonal embrace, whether it's crisp autumn air or the languid heat of summer. If you find this voyage soothing, enlightening, or simply a peaceful way to end your day, I'd be ever so grateful if you gave the video a like and perhaps subscribed. It helps this little corner of cosmic calm reach others who might need a tranquil pause in their evening too. Now, I do hope this isn't so captivating that it keeps you awake, but if it does, well, at least you'll drift off, knowing something beautiful about our planet's yearly dance through space. So settle in, breathe slowly, and let's begin. Because somewhere between ancient myths and modern astronomy, between the tilt of our world and the warmth of the sun, lies the story of why seasons change. Seasons have this wonderful way of sneaking up on us, don't they? One day you're reaching for a light jacket and suddenly you realize the trees have painted themselves gold. Or you step outside expecting spring's gentle kiss, only to find summer has arrived in full, blazing glory. Yet, for all their familiarity, seasons remain curiously mysterious to most of us. We know they happen, we feel their effects, we plan our lives around them, but the actual reason why they exist, the cosmic mechanics behind this yearly transformation, often remains as hazy as a morning mist. The answer begins not with weather or temperature, but with a dance that started over 4.5 billion years ago when our planet was young and the solar system was still finding its rhythm. Earth, you see, doesn't stand perfectly upright as it orbits the sun. Instead, our world tilts at an angle of about 23.5 degrees. Imagine a spinning top that's begun to wobble just slightly, but maintains that wobble consistently as it moves. That's essentially what Earth does as it travels its yearly path around our star. This tilt is the secret, the quiet choreographer of our seasons. As Earth journeys around the sun, taking 365.25 days to complete its orbital dance, different parts of our planet receive varying amounts of direct sunlight throughout the year. When the northern hemisphere is tilted toward the sun, it experiences summer, while the southern hemisphere, tilted away, endures winter. 6 months later, the situation reverses. The southern hemisphere leans into the sun's embrace, experiencing its summer, while the north tilts away into winter's cooler touch. But here's where it gets beautifully complex. It's not simply about being closer to or farther from the sun. In fact, Earth is actually closest to the sun in early January, during winter in the northern hemisphere. A delightful cosmic irony that confused early astronomers. No, the key lies in the angle at which sunlight strikes our planet. When the sun's rays hit directly, they're concentrated, delivering more energy per square area. When they strike at a shallow angle, they're spread out like butter on too much bread, delivering less warmth per square area. Think of it like holding a flashlight directly above a table versus shining it at an angle. The direct beam creates a bright, concentrated circle, while the angled beam creates a larger, dimmer oval. The same amount of light is there, but it's distributed differently. This is why tropical regions near the equator remain warm year-round. They consistently receive relatively direct sunlight. Meanwhile, polar regions experience extreme seasonal variations as they swing from months of constant daylight to months of perpetual darkness. The length of daylight hours also plays a crucial role. During summer in your hemisphere, not only does the sun climb higher in the sky, delivering more concentrated energy, but it also stays visible longer, giving more time to warm the air and ground. During winter, the sun takes a lower, lazier path across the sky and disappears much earlier, leaving longer nights for heat to radiate away into space. This is why summer evenings can remain warm long after sunset, while winter afternoons can feel chilly even with bright sunshine. Our planet's axial tilt also creates those magical transition periods we call spring and autumn. During these seasons, neither hemisphere is significantly tilted toward or away from the sun. Day and night become roughly equal in length and temperatures moderate, creating those perfect days when you can wear just a light sweater and feel completely comfortable. These equinoxes mark the moments when Earth's axis is perpendicular to the line connecting us to the sun, and the entire planet experiences roughly 12 hours of daylight and 12 hours of darkness. But seasons aren't uniform across our planet. The closer you live to the equator, the less seasonal variation you experience, because even when tilted, the angle of incoming sunlight doesn't change dramatically. Meanwhile, if you live near the poles, you experience extreme seasonal swings, from the midnight sun of summer, when the sun never sets, to the polar night of winter, when it never rises. These polar regions showcase our planet's tilt in its most dramatic form. Interestingly, our northern and southern hemispheres experience opposite seasons simultaneously. While families in North America are building snowmen and sipping hot chocolate, families in Australia are heading to the beach and firing up barbecues. It's a beautiful reminder that Earth is always experiencing the full spectrum of seasonal moods, just in different places at different times. Christmas in July isn't just a quirky saying. In the southern hemisphere, it's a reality complete with summer heat and longer days. The timing of seasons also creates some fascinating cultural differences. Many northern hemisphere cultures associate harvest time with autumn, cooler weather, and preparation for winter. But in agricultural regions of the southern hemisphere, harvest might coincide with what northern calendars call spring. The same cosmic dance creates different rhythms of life depending on where you call home. Our seasonal cycle also influences life in profound ways. Plants have evolved to sync their growth, reproduction, and dormancy with seasonal light and temperature changes. Animals migrate, hibernate, or change their behavior based on seasonal cues. Even human societies have structured themselves around seasonal rhythms, with everything from school calendars to fashion industries following the predictable ebb and flow of our planet's yearly journey. The tilt that creates our seasons wasn't always 23.5 degrees. Over very long periods spanning thousands of years, Earth's axial tilt varies slightly between about 22 and 24.5 degrees. This variation, combined with changes in the shape of Earth's orbit, helps drive long-term climate patterns, including ice ages. These Milankovitch cycles, named after the Serbian astronomer who described them, show how even small changes in our planet's orientation can have dramatic effects over geological time. Some planets in our solar system experience much more extreme seasonal variations. Uranus, for example, is tilted at about 98 degrees, essentially rolling on its side as it orbits the Sun. This means each pole experiences 42 years of continuous daylight followed by 42 years of continuous darkness. Talk about extreme seasons. Meanwhile, Venus spins so slowly that its day is longer than its year, making seasonal changes almost meaningless. Mars, with a tilt similar to Earth's, experiences seasons too. But because its orbit is more elliptical and its year is nearly twice as long, Martian seasons last much longer and vary more dramatically in intensity. The red planet's southern summer coincides with its closest approach to the Sun, making southern summers much hotter than northern ones, while southern winters are correspondingly more severe. Our moon also plays a subtle role in seasonal stability. Earth's large moon helps stabilize our axial tilt, preventing it from wobbling chaotically over time. Without this lunar influence, our planet might experience wild variations in tilt, leading to unpredictable and potentially catastrophic climate swings. It's another reminder that our seasonal cycle, while feeling perfectly natural and inevitable, actually depends on a delicate cosmic arrangement. The beauty of seasons lies not just in their cosmic cause, but in their earthly effects. The way autumn light slants golden through bare branches, the way spring arrives with an explosion of green, the way summer heat makes everything feel languid and timeless, the way winter's clarity makes stars seem brighter and closer. Each season carries its own palette of colours, its own soundtrack of sounds, its own catalogue of scents. Seasons also give rhythm to human life. They mark the passage of time in ways that feel meaningful, creating natural chapters in our personal stories. We remember the summer we learned to swim, the autumn we started school, the winter we fell in love, the spring we graduated. These seasonal memories anchor our experiences in time and place, creating a sense of continuity and change that feels both comforting and exciting. Even in our modern climate-controlled world, where we can experience artificial spring in the depths of winter or Arctic air conditioning during summer heat waves, we still feel the pull of seasons. Our bodies respond to changing daylight with shifts in sleep patterns and mood. Our souls seem to crave the variety that seasons provide. The renewal of spring, the abundance of summer, the preparation of autumn, the reflection of winter. As you lie there tonight, perhaps you can sense the season outside your window. Maybe it's the deep quiet of snow muffling sound, or the gentle stirring of spring air, or the thick warmth of summer darkness, or autumn's crisp clarity. Whatever season surrounds you right now, it's the result of our planet's ancient tilt, our yearly dance around the sun, a cosmic waltz that's been playing the same beautiful rhythm for billions of years. So the next time you notice the seasons changing, when you feel that first hint of autumn in the summer air or catch spring's earliest whisper in winter's cold, remember that you're experiencing something truly cosmic. You're feeling the effects of our planet's orientation in space, the angle at which sunlight kisses our world, the delicate choreography of Earth and Sun that creates the eternal cycle of renewal that makes our world so beautifully alive. And isn't there something wonderfully reassuring about that? No matter what changes in our daily lives, no matter how chaotic the world might seem, the seasons will continue their ancient dance. Spring will follow winter, summer will bloom from spring, autumn will paint the world in fire, and winter will bring its crystalline peace. Now, as we drift a bit further through this cosmic story, let's pause for a moment to consider something rather extraordinary. We've seen how Earth's tilt creates our seasons, how different hemispheres experience opposite cycles, and how this celestial choreography has shaped life itself. But there's something deeper here, something that connects us to the very fabric of existence in ways that might surprise you. You see, these seasonal rhythms we've been exploring aren't just astronomical curiosities or climate patterns to memorize for a geography exam. They're actually ancient heartbeats, cosmic pulses that have been drumming through the universe for billions of years, long before the first human ever looked up at the sky and wondered why leaves change colour, or why some days feel longer than others. Think about it for a moment. Every breath you take, every meal you eat, every moment of weariness or energy you feel throughout the year is subtly influenced by this grand celestial dance. Your body, evolved over countless generations, carries within it an internal compass that responds to these seasonal shifts. 5-degree tilt we discussed earlier whispered through your biology across eons of adaptation. During the depths of winter, when your hemisphere tilts away from the sun and daylight becomes a precious, fleeting thing, your body produces more melatonin. You might find yourself craving heartier foods, feeling a gentle pull toward rest and introspection. This isn't laziness or seasonal blues, though those can certainly occur. It's your ancient biology responding to signals that have guided life on Earth since long before cities or calendars existed. And then, as spring arrives and the days grow longer, something remarkable happens. That same biological compass begins to shift. Serotonin levels rise, energy increases, and you might notice an almost irresistible urge to clean, to organize, to begin new projects. Spring cleaning isn't just a cultural tradition, it's a biological imperative written into your very cells by millions of years of seasonal adaptation. But here's where it gets truly fascinating. These seasonal cycles don't just affect individual organisms, they orchestrate entire ecosystems with a precision that would make the finest conductor envious. Consider the timing of a forest in spring. It's not random that tree buds burst just as soil temperatures reach certain thresholds, or that migrating birds arrive precisely when insects emerge, or that flowers bloom exactly when their pollinators are most active. This intricate timing, what scientists call phenology, represents one of nature's most elegant solutions to the challenge of survival. Every species has evolved to read the seasonal signals, the length of days, the angle of sunlight, the temperature patterns, and to time their most crucial life events accordingly. Reproduction, migration, hibernation, seed dispersal, all of it choreographed by that fundamental rhythm of Earth's tilted journey around the sun. Take the humble maple tree, for instance. Throughout the summer, it's been busy converting sunlight into sugars, storing energy in its roots and trunk. But as autumn approaches and daylight hours shorten, something magical begins to happen. The tree starts to withdraw chlorophyll from its leaves, revealing the brilliant reds, oranges, and yellows that were there all along, masked by the green of active photosynthesis. This isn't just a beautiful display for our enjoyment, though we certainly benefit from it. It's a carefully orchestrated process of resource management. The tree is essentially harvesting valuable nutrients from its leaves before discarding them, preparing for the long winter ahead when photosynthesis will be impossible. The timing must be perfect. Too early and valuable growing time is lost. Too late, and the first hard freeze will damage the leaves before the nutrients can be recovered. Now imagine this process multiplied across millions of trees, thousands of species, entire continents of life, all responding to the same celestial signals. The result is what we call the changing seasons, but it's really a planetary symphony, with Earth's tilt as the conductor's baton guiding every note. And we humans, despite our technology and urban environments, remain very much part of this symphony. Studies have shown that people living in higher latitudes, where seasonal changes are more pronounced, often experience more dramatic mood and energy fluctuations throughout the year. This isn't a flaw in human design, it's evidence of our deep connection to these ancient rhythms. Even our cultural traditions reflect this seasonal attunement. Harvest festivals in autumn, celebrations of light during the darkest part of winter, renewal rituals in spring, and community gatherings during the long days of summer. These aren't arbitrary customs, they're collective expressions of our species' biological and psychological response to seasonal change. But perhaps, most remarkably, these seasonal patterns have profoundly influenced human civilization itself. The development of agriculture, the rise of permanent settlements, the creation of calendars and the measurement of time, all of these fundamental building blocks of human society emerged from our need to understand and work with seasonal cycles. Early farmers had to become amateur astronomers, learning to read the subtle signs that indicated when to plant, when to harvest, when to prepare for winter. They developed sophisticated understanding of how the sun's path across the sky changed throughout the year, how the constellations shifted with the seasons, how the phases of the moon related to optimal planting times. This knowledge was so crucial for survival that it became embedded in mythology, religion, and cultural practice. Stonehenge, the pyramids of Egypt, the temples of ancient Maya, all of these monuments incorporate precise astronomical alignments that reflect humanity's deep engagement with seasonal cycles. They're not just impressive architecture, they're calendars carved in stone, permanent reminders of our species' relationship with the cosmic forces that govern our planet. And here's something that might give you pause as you settle in for the night. Right now, as you listen to these words, you are participating in this ancient dance. The earth beneath you is spinning on its tilted axis, carrying you through space at thousands of miles per hour. The hemisphere you're in is either tilting toward or away from the sun, slowly but steadily changing the angle at which sunlight strikes your part of the world. Tomorrow, the sun will rise at a slightly different time than it did today. The shadows will fall at subtly different angles. The amount of daylight will be imperceptibly longer or shorter. These changes are so gradual that you won't notice them from day to day, but over weeks and months they accumulate into the grand seasonal transitions that mark the rhythm of life on Earth. So, as we continue our sleepy journey through the cosmos, remember that you're not just an observer of these celestial mechanics. You're an active participant, a note in that planetary symphony, a small but essential part of the grand seasonal story that has been unfolding for billions of years and will continue long after we're gone. 5-degree tilt and an elliptical orbit, yes. So here's where things get beautifully complex and absolutely fascinating. We've been talking about seasons as if Earth exists in its own little bubble, spinning and tilting through space in perfect isolation. But our planet doesn't dance alone. It's part of an intricate celestial waltz, influenced by gravitational partners that stretch across millions of years, subtly tugging and nudging our seasonal rhythms in ways that have shaped the very history of life itself. 5-degree tilt, that fundamental driver of our seasons, isn't actually constant. It wobbles, it shifts, it changes over vast periods of time in what scientists call Milankovitch cycles, named after the Serbian mathematician who first described them in the early 20th century. These cycles operate on timescales that make human civilization look like a brief flicker. Yet their effects have been profound enough to trigger ice ages, reshape continents, and drive the evolution of countless species. There are 3 main components to these cycles, each operating on its own timeline, each adding its own subtle influence to Earth's climate dance. The first is called precession, sometimes poetically referred to as the wobble of Earth's axis. Imagine a spinning top as it begins to slow down, the way its axis traces out a slow circle. Earth does something similar, though much more gradually. Our planet's rotational axis traces out a complete circle roughly every 26,000 years. This means that the North Star, Polaris, won't always be our guiding light. In about 13,000 years, the bright star Vega will hold that honour instead. But precession does more than change our celestial landmarks. It affects when seasons occur relative to Earth's position in its elliptical orbit around the Sun. Currently, winter solstice in the Northern Hemisphere happens when Earth is closest to the Sun, while summer solstice occurs when we're farthest away. But 13,000 years ago, this was reversed. Northern Hemisphere winter occurred when Earth was farthest from the Sun, making winters colder and summers warmer than they are today. It's a slow-motion seasonal seesaw that takes millennia to complete each swing. The second cycle involves changes in Earth's axial tilt itself, what scientists call obliquity. 5-degree angle we've been discussing isn't fixed. 5 degrees over a period of roughly 41,000 years. When the tilt is greater, seasons become more extreme, summers get hotter, winters get colder, and the differences between them become more pronounced. When the tilt is smaller, seasons become gentler, more moderate. We're currently somewhere in the middle of this range, gradually decreasing toward the minimum tilt. Think about what this means for a moment. There have been times in Earth's past when our planet leaned more dramatically into space, when the Arctic received even less winter sunlight and even more summer heat than it does today. There have been other times when Earth stood more upright, when seasonal differences were muted, when the poles experienced milder winters and cooler summers. Each extreme would have created vastly different climate conditions, different patterns of ice and vegetation, different challenges and opportunities for life. The third cycle, operating on the longest timescale, involves the shape of Earth's orbit itself. our planet's path around the Sun isn't a perfect circle, it's an ellipse, and that ellipse changes shape over time. Sometimes it's more circular, sometimes more stretched out. This cycle, called eccentricity, operates over periods of about 100,000 and 400,000 years. When Earth's orbit is more elliptical, the difference between our closest and farthest approaches to the Sun becomes more pronounced, amplifying seasonal effects. When the orbit is more circular, these differences diminish. What makes these cycles particularly fascinating is how they interact with each other. Sometimes they align with precession, obliquity, and eccentricity, all pushing climate in the same direction. Other times they work against each other, with one cycle trying to warm the planet while another tries to cool it. The interplay creates complex patterns that scientists are still working to fully understand. These orbital cycles don't just influence seasons, they drive them on geological timescales. Ice ages, those massive expansions of glaciers that have periodically covered much of North America and Europe, correlate strongly with Milankovitch cycles. When the cycles combine to reduce summer sunlight in northern latitudes, snow that falls in winter doesn't fully melt in summer. Year after year, it accumulates, compacts, and eventually forms the massive ice sheets that define glacial periods. The last ice age ended roughly 11,000 years ago, corresponding to changes in Earth's orbital cycles that brought more summer sunshine to northern latitudes. The great ice sheets that once covered Canada and Scandinavia melted, sea levels rose, and the climate patterns we recognize today began to establish themselves. But this isn't the end of the story. The cycles continue, and based on orbital mechanics alone, Earth should gradually be cooling toward the next ice age over the coming millennia. Of course, human activities have now introduced a new variable into this ancient equation. The greenhouse gases we've added to the atmosphere are warming the planet far more rapidly than orbital cycles typically cool it. We're conducting an unprecedented experiment, overlaying rapid human-driven climate change onto the slow, steady rhythms that have governed Earth's climate for millions of years. But let's step back from the immediate concerns of our current moment and consider the deeper implications of these cycles. They remind us that the seasons we experience today, the patterns we consider normal and stable, are actually just one snapshot in an incredibly long and dynamic story. The spring that brings cherry blossoms to your neighborhood, the summer that ripens tomatoes in your garden, the autumn that paints leaves in brilliant colors, the winter that blankets the landscape in snow. These familiar rhythms exist within much larger rhythms, cycles within cycles that stretch across geological time. Indigenous cultures around the world have long recognized these deeper patterns. Many traditional calendars and seasonal observations account for variations that operate on longer timescales than individual human lifetimes. They understood that nature operates on multiple rhythms simultaneously, from the daily cycle of sunrise and sunset to the annual cycle of seasons to much longer patterns that require generations of observation to perceive. Modern science has given us the tools to see these patterns more clearly, to understand the orbital mechanics behind them, and to predict how they'll unfold over future millennia. But in some ways, this knowledge makes the experience of seasons even more profound. When you feel the first warm breeze of spring or notice the changing angle of autumn light, you're experiencing not just the result of Earth's current tilt and orbit, but the culmination of cosmic cycles that have been operating since our planet first formed. The seasons, it turns out, are both utterly familiar and completely mysterious. They're the result of simple physics, the predictable consequence of a tilted planet orbiting a star. But they're also part of an intricate cosmic dance that connects us to the deepest history of our solar system, to ice ages and warm periods, to the rise and fall of species, to the very evolution of life itself. And perhaps most remarkably, these vast cycles that operate over hundreds of thousands of years have created the conditions for beings like us to exist, to notice the changing seasons, to wonder about their causes, and to discover our place in the larger cosmic story. We are, in a very real sense, children of these orbital cycles, products of the long dance between Earth and Sun that has created the stable, seasonal world in which human civilization could emerge and flourish. So the next time you notice the days getting longer or shorter, the next time you feel the particular quality of light that belongs to your favourite season, remember that you're experiencing something both intimately personal and cosmically vast. Now that we understand the cosmic clockwork of seasons, let's explore how these patterns reach far beyond simple weather changes and into something much more profound. They touch the very foundations of life itself, shaping ecosystems in ways that are both subtle and spectacular, delicate and dramatic. Think about it for a moment. Every leaf that changes colour, every bird that migrates, every bear that hibernates is responding to the same celestial dance we've been following. The Earth's tilt doesn't just give us winter coats and summer holidays, it orchestrates one of the most intricate symphonies of survival you could possibly imagine. Let's start with something you've probably noticed, but might not have fully appreciated. Trees, those quiet giants standing in your neighbourhood, in parks, along streets, are actually master timekeepers. They don't just passively endure the seasons, they actively prepare for them months in advance. As daylight hours begin to shorten in late summer, trees start withdrawing nutrients from their leaves, breaking down the green chlorophyll that's been busy capturing sunlight all season long. What's left behind are the yellows, oranges and reds that make autumn such a visual feast. But here's what's really fascinating. This isn't just about looking pretty for our Instagram photos. This process, called senescence, is a carefully orchestrated retreat. The tree is essentially packing up shop, storing energy in its roots and trunk for the long winter ahead. It's like a business owner moving all the valuable inventory to a secure warehouse before a storm hits. Every nutrient that can be salvaged gets pulled back into the tree's core, ready to fuel next spring's growth. And it's not just deciduous trees doing this seasonal dance. Evergreen trees, those stoic conifers that seem to ignore the changing seasons entirely, have their own strategies. Their needle-shaped leaves are designed to minimize water loss during winter, and they're coated with a waxy substance that acts like natural antifreeze. They don't shed their leaves because they've built themselves to weather the storm year-round. It's two completely different approaches to the same seasonal challenge. Now animals take this seasonal preparation to an entirely different level. Migration might be one of the most mind-boggling responses to Earth's tilt that exists in nature. Arctic terns, those seemingly delicate seabirds, undertake a journey that puts every human traveller to shame. They fly from Arctic to Antarctic and back again every year, following summer around the globe like they're chasing an eternal season. We're talking about a round trip of roughly 44,000 miles. These birds experience more daylight than any other creature on Earth because they're literally following the sun. But migration isn't just about birds. Monarch butterflies, weighing less than a paperclip, somehow navigate thousands of miles from Canada to Mexico using a combination of magnetic fields, sun position, and genetic memory. The butterflies that make the journey south aren't even the same ones that will return north the following spring. It takes multiple generations to complete the cycle, which means these tiny creatures are carrying inherited maps they've never used before. It's like having GPS coordinates written into your DNA for places you've never been. Then there's hibernation, which is essentially nature's version of time travel. Bears don't just take a long nap, they fundamentally alter their metabolism. Their heart rate drops dramatically, their breathing slows, and their body temperature decreases just enough to conserve energy without causing damage. They're essentially running their bodies on the biological equivalent of power-saving mode for months at a time. Some animals take this even further. Ground squirrels can drop their body temperature below freezing and still survive, entering a state so close to death that they barely register as alive. But seasonal changes don't just affect individual species, they choreograph entire ecosystems. Spring doesn't just mean flowers bloom and birds return. It triggers a carefully timed cascade of events that has to unfold in precisely the right order, or the whole system starts to wobble. Consider the relationship between flowering plants and pollinators. Apple trees need to bloom exactly when bees are active and ready to collect nectar. Too early, and there are no bees. Too late, and the bees have moved on to other food sources. This timing, called phenology, has been fine-tuned over thousands of years. The trees, the bees, the weather patterns, they're all synchronized like instruments in an orchestra. Climate change is starting to disrupt these ancient rhythms in ways that are both subtle and concerning. Some plants are blooming earlier as temperatures rise, but their pollinators haven't adjusted their schedules accordingly. Birds are arriving at breeding grounds to find that the insects they depend on have already peaked and declined. It's like showing up to a concert to find the orchestra has already finished the symphony and gone home. In aquatic ecosystems, seasonal changes drive everything from fish spawning to algae blooms. Salmon return to their birth rivers with timing so precise it seems almost supernatural. They navigate thousands of miles of ocean to arrive at exactly the right moment when water temperatures and flow rates are optimal for spawning. These fish are responding to seasonal cues that include everything from water temperature to the length of daylight, creating a biological calendar that's more accurate than most human scheduling systems. Even the soil beneath our feet responds to seasonal changes in ways that affect entire food webs. Soil microorganisms become more active as temperatures warm, breaking down organic matter and releasing nutrients that plants need for spring growth. Earthworms adjust their depth based on soil temperature and moisture, aerating the earth and processing organic matter. The seasonal cycle doesn't just happen above ground, it pulses through the entire underground ecosystem as well. Seasonal changes also drive reproduction cycles across countless species. Many animals time their breeding so that their offspring arrive during the most favourable conditions. Deer give birth in late spring when food is abundant and weather is mild. Sea turtles return to beaches to lay eggs when sand temperatures are perfect for incubation. Even microscopic organisms adjust their reproductive cycles to seasonal patterns, creating population booms and busts that ripple through entire food chains. In forests, the seasonal cycle creates distinct layers of activity throughout the year. Spring brings the understory to life as wildflowers bloom before the tree canopy fills in and blocks the sunlight. Summer sees peak photosynthesis and growth in the upper canopy. Autumn triggers seed dispersal and preparation for winter. Winter becomes a time of rest and conservation, with most growth and activity slowing to a crawl. Wetlands showcase some of the most dramatic seasonal transformations. Marshes and swamps that are vibrant with life in summer can become eerily quiet in winter, with many birds migrated south and amphibians buried in mud at the bottom of ponds. Spring brings explosive activity as frogs emerge to breed, filling the air with choruses that can be heard for miles. These ecosystem responses to seasonal change reveal something profound about how life adapts and thrives. The Earth's tilted axis doesn't just create weather patterns, it creates opportunities. The seasonal cycle provides different niches, different resources, different challenges that allow for incredible diversity. Some species specialize in exploiting brief seasonal windows, like flowers that bloom for just a few weeks each year. Others have learned to take advantage of the entire seasonal cycle, adjusting their behavior and physiology as conditions change. What's perhaps most remarkable is how these seasonal patterns create stability through change. Ecosystems that experience dramatic seasonal variations often prove more resilient than those with constant conditions. The seasonal cycle creates a kind of reset button, clearing out weak or diseased organisms, redistributing nutrients, and providing opportunities for new growth and adaptation. The relationship between Earth's seasons and life is far more than simple cause and effect. It's a dynamic partnership that has shaped the evolution of virtually every living system on our planet. Every migration route, every hibernation strategy, every flowering schedule is a testament to life's remarkable ability to not just survive seasonal change, but to thrive because of it. As we drift towards sleep, perhaps we can appreciate that we're part of this ancient seasonal rhythm too. Our own bodies respond to changing daylight, shifting our sleep patterns and energy levels in ways we're only beginning to understand. Now, here's where things get truly fascinating. Our cosmic clockwork doesn't just tick away quietly in the background. Oh no. It reaches into every corner of life on Earth, orchestrating the most intricate ballet you've probably never thought about. From the tiniest microbe to the mightiest whale, from the humblest daisy to the tallest redwood, every living thing is dancing to the rhythm of our tilted, spinning, orbiting planet. And we humans, well, we've been swept up in this dance for so long that it's written into our very bones, our cultures, our stories, and our souls. Let's begin with something you witness every spring but might never have truly considered. Why do cherry trees know to bloom in April rather than August? Why do birds suddenly feel the urge to fly thousands of miles just as the days grow shorter? The answer lies in something called phenology, the study of nature's calendar. Plants and animals don't just respond to temperature, they're actually reading the subtle changes in daylight duration, temperature patterns, and even atmospheric pressure that come with our planet's seasonal dance. Take the cherry tree, for instance. It's not just waiting for warm weather. Instead, it's been counting chilly days through winter, a process called vernalization. The tree needs a certain number of cold hours to prepare for spring, and then it measures the gradually lengthening days through specialized light-sensitive proteins in its buds. When the combination is just right, the internal chemistry shifts, hormones flow, and suddenly those magnificent blossoms unfurl like nature's own fireworks display. Miss the timing, and there's no second chance until next year. Birds are even more remarkable in their seasonal precision. Arctic terns, those extraordinary wanderers, migrate from Arctic to Antarctic and back again every year, covering roughly 40,000 miles. But they're not just following the weather, they're following the very tilt of our planet. As Earth's axial tilt creates longer days in the northern hemisphere during our summer, these birds feast on the abundant fish in polar waters where the sun barely sets. Then, as our hemisphere tilts away from the sun and days shorten, they begin their epic journey south to catch the opposite season in Antarctica. They're literally chasing summer around the globe, riding the wave of our planet's seasonal rhythm. The timing has to be exquisite. Leave too early and they miss the peak feeding opportunities. Leave too late and harsh weather makes the journey treacherous. So how do they know? Scientists have discovered that birds can sense incredibly subtle changes in day length, sometimes detecting variations of just a few minutes. Their brains contain tiny clusters of cells that act like biological light meters, tracking the sun's daily arc and triggering hormonal changes that create an almost irresistible urge to migrate. It's as if they're carrying tiny astronomical computers in their heads, but it's not just the grand migrations that depend on seasonal timing. Consider the humble honeybee, whose entire social structure revolves around the changing seasons. As spring arrives and flowers begin to bloom in their carefully orchestrated sequence, worker bees adjust their daily schedules. They know which flowers bloom at what time of day, which meadows will be richest at different points in the season, and even how weather patterns associated with seasonal changes will affect nectar production. A bee colony's survival depends on this precise choreography between their activities and the seasonal availability of resources. Now, here's where it gets even more intricate. Different species have evolved to take advantage of different seasonal niches, creating what ecologists call temporal partitioning. It's like nature's way of ensuring everyone gets a turn on the dance floor. Early spring flowers like crocuses and snowdrops bloom before trees leaf out, capturing sunlight that will soon be blocked by the forest canopy. Summer flowers peak when pollinators are most active. Late fall bloomers like asters provide crucial nectar when most other flowers have finished their show. This seasonal coordination extends deep into the soil as well. Earthworms, those unsung heroes of healthy soil, time their reproduction to coincide with spring warming and increased moisture. Soil microbes shift their activity patterns with temperature changes, breaking down organic matter faster in warm months and slowing their work as winter approaches. Even the chemistry of soil changes seasonally, with different nutrients becoming available at different times of year, perfectly synchronized with when plants need them most. The precision of these natural rhythms becomes even more impressive when you consider how climate change is beginning to disrupt them. Scientists are documenting what they call phenological mismatches, where the careful timing that evolved over thousands of years begins to break down. Spring flowers might bloom before their pollinators emerge from winter dormancy. Birds might arrive at breeding grounds before their preferred insects are active. Predators might miss the peak abundance of their prey species. But let's step back from the potential disruptions and marvel at how beautifully the system has worked for millennia. The seasonal patterns we've explored aren't just biological curiosities, they're the foundation of every ecosystem on Earth. They create the rhythm that allows forests to grow, grasslands to flourish, and wetlands to support incredible diversity of life. And then there are the longer cycles, the ones that stretch beyond individual seasons into years and decades. Massed years, those periodic bonanzas when oak trees, beech trees, or bamboo plants produce enormous quantities of seeds, often happen in sync across vast areas. Scientists believe these coordinated events, sometimes occurring every few years or even decades apart, are responses to longer climate cycles and serve to overwhelm seed predators while ensuring successful reproduction. Some bamboo species take this to an extreme, growing vegetatively for 60 to 70 years, then flowering simultaneously across entire continents before dying. The evolutionary advantage seems to be that by synchronizing their reproduction over such vast areas and long time periods, they ensure that seed predators cannot possibly consume all the seeds produced. It's a strategy that depends not just on seasonal timing, but on multi-decade environmental cycles. Even more fascinating are the species that seem to dance to rhythms we're only beginning to understand. Cicadas, those noisy heralds of summer, spend most of their lives underground as nymphs, emerging en masse every 13 or 17 years depending on the species. The mathematical precision of these prime number cycles may help them avoid synchronizing with predator populations, but the exact environmental triggers that tell millions of insects it's time to emerge remain one of nature's most intriguing mysteries. Consider too how seasonal changes create cascading effects through entire food webs. When spring arrives early due to climate variation, it doesn't just affect individual species, it ripples through every level of the ecosystem. Earlier snowmelt changes the timing of stream flows, affecting aquatic insects, which affects the fish that eat them, which affects the bears that catch the fish, which affects the berry bushes that benefit from bear-dispersed fertilizer. Every connection in the web of life pulses with seasonal rhythm. The beauty of these natural cycles extends even to the microscopic level. Phytoplankton, the tiny floating plants that form the base of most marine food webs, respond to seasonal changes in sunlight, temperature, and nutrient availability. Their population booms and busts create seasonal patterns in ocean color visible from space. These microscopic organisms, following the same seasonal cues that guide cherry blossoms and migrating birds, produce much of the oxygen we breathe and absorb enormous quantities of carbon dioxide from the atmosphere. What emerges from all of this is a picture of Earth as a living system, where the rhythm of seasons, created by our planet's tilt and orbit, has become the fundamental timekeeper for life itself. Every species, from the smallest bacteria to the largest mammals, has evolved not just to survive in different seasonal conditions, but to thrive by synchronizing their life cycles with the predictable changes that come with our planet's cosmic dance. The seasons aren't just something that happens to life on Earth, they're woven into the very fabric of how life works. And in the end, perhaps the most beautiful part of our seasonal story isn't just how Earth tilts and spins through space, or how this cosmic dance creates the rhythms of warmth and cold that paint our world in endless cycles. No. The real magic lies in how deeply woven we are into this pattern, how every breath we take, every heartbeat, every quiet moment of watching leaves fall or flowers bloom connects us to something far grander than ourselves. Think about it for a moment. The seasons aren't just something that happens to us, they happen through us. We are part of this ancient choreography. Our bodies and minds are tuned to subtle changes in light and temperature that our ancestors felt thousands of years ago. When you feel that first hint of spring stirring in your chest, or that melancholy pull of autumn evenings, you're experiencing the same cosmic forces that have shaped life on this planet for billions of years. The seasons remind us that change isn't just inevitable, it's necessary. Without Earth's tilt, without that gentle wobble that brings us winter's rest and summer's abundance, our planet would be a very different place. One hemisphere would bake in eternal summer while the other froze in perpetual winter. There would be no migration of birds across continents, no deciduous forests painting themselves in brilliant reds and golds, no hibernating bears or flowering meadows or harvest moons. But more than that, the seasons teach us about resilience and adaptation. Every tree that drops its leaves in autumn is preparing for survival, conserving energy for the harsh months ahead. Every bird that flies thousands of miles to find warmth is following an ancient wisdom encoded in its very cells. Every flower that pushes through the last snow of spring is participating in a triumph of life over dormancy that has played out countless times before. We humans have learned to dance with these rhythms too, in ways both obvious and subtle. Our cultures have grown around seasonal celebrations. Our agriculture depends on understanding when to plant and when to harvest. Our bodies still respond to the lengthening days of spring with renewed energy, and to the shorter days of winter with a desire to slow down, to rest, to turn inward. And here's something wonderful to consider as you drift towards sleep. Earth's seasons connect us not just to our own planet's history, but to the vast cosmos beyond. Every star system that harbours a tilted, orbiting world will have its own version of seasons. Somewhere out there, perhaps, other forms of life are experiencing their own cycles of growth and rest, their own versions of spring's awakening and winter's quiet. The story of seasons is ultimately a story about time itself, about how celestial mechanics create the rhythms that make life not just possible, but beautiful. It's about how a 23.5-degree tilt, maintained over millions of years, has given us poetry and harvest festivals, migration routes and sleeping bears, the smell of autumn leaves, and the first green shoots of spring. As you settle into whatever season surrounds you now, whether it's the deep cold of winter or the buzzing warmth of summer, remember that you're part of something magnificent. The same cosmic forces that guide planets in their orbits and tilt our world toward and away from the sun are the forces that bring you the changing light outside your window, the shifting temperatures that make you reach for a sweater or step outside in bare feet. The seasons will continue their eternal dance long after we're gone, but right now, in this moment, you get to be part of it. You get to feel the way sunlight slants differently through your window as Earth traces its elliptical path around our star. You get to experience the ancient rhythm that connects you to every living thing that has ever felt the turn of seasons, from the smallest sprouting seed to the largest migrating whale. So rest well knowing that you're held by forces both gentle and powerful, that tomorrow the sun will rise at a slightly different angle than today, that the seasons will continue their slow, patient work of renewal and rest, growth and dormancy, life and the quiet spaces that make life possible. We hope you enjoyed the story tonight. Before we end our journey, can you comment where you're watching from? Also, let us know what time it is there. We love to hear people joining us from around the world to be a part of our community. Also, don't forget to leave a like and subscribe if you enjoy this story. Good night, fellow space explorer.